Imagine that you are a tiny parasite, looking for a place to live. A mosquito has kindly dropped you off into some poor unsuspecting person, and you shuffle your way to the liver. You might set up here for a little while, recuperate and grow, but you can't shake the feeling that this just doesn't feel quite homely enough. And if you're anything like the parasites that I work with, the ones that cause malaria, you know that your dream home is out there. These parasites figured out that red blood cells are a great place to call home. Red blood cells float around in a rich soup of sugar and other nutrients, providing plenty of food for nourishing, bustling baby parasites. And if you live inside a red blood cell, it's much easier to avoid their big bad cousins, the white blood cells, which make up the immune system. But there's also some challenges to living inside red blood cells. Because they're so focused on their job of delivering oxygen around the body, these cells have basically gotten rid of everything that doesn't help them do it. They basically chucked out all the furniture to make more room for oxygen. So when the parasite moves in, it truly makes itself at home, renovating, redecorating, and even bringing in its own furniture. For the most part, the renovation project goes well. It's got the bedroom, the bathroom, the nursery, but the parasite's kitchen leaves a little to be desired. It's got enough to make the basics, but it just doesn't have the right appliances for cooking up cholesterol. And these hungry little parasites love cholesterol. In fact, they need it to survive, so they figured out ways to steal it. Luckily for the parasites, there tends to be quite a bit of cholesterol floating around in human blood, a bit too much in some people. But what happens if we dry up the supply chain? If they can't make it, and they can't steal it, then maybe we can starve them out. We already have a whole range of drugs which lower blood cholesterol. We use them to prevent heart disease. These drugs are cheap to produce and safe to use, and we know that they can kill malaria parasites in the lab. But before we start doling out the drugs, it's important to know exactly how they work, and this is where my research comes in. My PhD looks at the way that malaria parasites get a hold of cholesterol, and what they do once they've got their hands on it. I'm trying to figure out exactly where they get it from, how much they're taking, and which pantry they store it in once they've got it. Are they taking more than they need, or just enough for a delicious dinner? I'm studying this by serving up some tasty treats, which might taste like cholesterol to the parasite, but with a key difference. This cholesterol has bright glowing lights attached to it, so I can literally watch where it comes from and where it goes. I'm also putting my parasites through a game of survival. Just how much do I have to deprive them of their favourite food before they start to suffer? But before you accuse me of being too cruel, remember that these parasites kill hundreds of thousands of people every year. And by understanding more about the ways that they use and rely on cholesterol, I'm hoping that we can use the same drugs that we use to prevent heart disease to help prevent malaria.